Welcome to Pavithra Laptop Care. So today's topic, how a motherboard talks. Okay, how it communicates. See, in the world, so many technicians are there. Million, billion technicians are there in the worldwide. Okay, their aim is they have to rectify the problem and give to customer, and they have to earn the money. Okay, but so many or approximate 80% technicians won't be knowing some facts. Okay, means technically I'm talking about technically professionally they won't be a technician. For them, one of them who are not professionally technician, so for them this particular video. Okay, see, for them I am going to ask a question. So this is the motherboard. So each and every component they know what it is: capacitor, resistor, IO, processor, PCH, and so on. Connectors, jacks, fan, bias, everything they know, right? But the one thing I wanted to ask, how it will talk to each other. If they don't have communication between these components, what will be the condition of this motherboard? Any guess? So that's the reason professionally first we need to understand what is motherboard and what is the usage and how it will communicate each other. See, in this motherboard, capacitors, resistors and inductors, these all are passive components. ICs and all active components. Those all are part of hardware, right? See, if only hardware part is there, then what will be the use? This board completely dead condition, right? Some ICs we call it's a smart ICs, embedded controller. Those called IO, PCH, processor, these all are comes under active smart components. Smart, why they called as a smart components? They can understand what are the components connected in this particular motherboard and what work it has to do according to our guidance. If we give a command, that particular task it has to do. That's why those particular ICs called smart ICs. Even chip also, I mean that processor also a kind of IC. Okay, integrated circuit. Right. See, in this motherboard, it contains processor, RAM, IO, and all. Those all are smart. How it will communicate? How it will talk to each other? So those things basically you must understand. Then only easily you can repair it. You can repair it without that also, no issues. Without that knowledge also you can do. But the thing is, knowledge is very, very important. Okay. So today's topic is the protocol. Through this protocol only those particular ICs will communicate. Okay. What are those protocols? You already heard. If I write this, so easily you can remember this. But that value you won't be knowing till now, right? So you will be doing the service, but the value won't be knowing. See, the one thing is the particular ICs. See, for example, IO to PCH to CPU. These three communicate using what? Protocol. What are those? One is I2C. Inter-integrated means here two I's will be there, or IIC. Inter-integrated circuits protocol. Second one is what? SPI. That bias chip you have seen, right? Bias chip. This one is not bias chip, this is SPI chip. Okay, note this point. This is not bias chip, this is SPI chip. Okay, this is for communication chip. And third one, UART. This also one technology. It's a very slow one, so that's why in our laptop thing this technology is not yet used. Maybe used in older laptops, but at present I'm not going to talk about this. Okay, I will talk about this one and this one. See, as I told, these two, using these two protocol, this we call it as a protocol. Using this protocol, these hardware things will become a smart components and talks to each other with, it communicates with components. What are the components? See, PCH will talk to IO, right? This one PCIe series, that is SDD, SSD, USB and so on. Here CPU, this talks to RAM. Talking in the sense communicating each other. Communicating each other. So that's called talk. See, what I am explaining, you people are listening and you can reply to me through the comment or phone call or telegram or WhatsApp, right? This is called two-way communication. See, this particular IO and PCH having two-way communication through SPI or LPC buses. This IO will talk to keyboard, right? And what is it? Touchpad also will be there. Sometimes, in some cases, touchpad and battery, right? This IO communicates with battery, keyboard, touchpad and charging IC. So let's take an example of this charging IC and IO. Okay. What first we will do, this is the DC jack. Sorry, this is DC jack. Right. Here positive, negative and ID will be there. Right, ID. This where it will go? It goes to IO. Right. So this IO will communicate with charging IC through what? You have heard two words, that SDA, SCL, clock and data. Right. It will communicate with this and it communicate with battery. In schematic I will show you how it will communicate. This communication bus we called SM bus. Okay. This communication series we call it as SM bus. So this is called I2C. The number one communication we call I2C, means integrated circuit. Okay, integrated circuit. It has SM bus path. It has two pull-up resistor. Clearly I'll show you. See, SM bus path, SMB. It has two pull-up. Okay. Through this two pull-up, one is data, one is clock, CLA. and connects to slave. One, two, again slave, and so on. Slave. See, through this SM bus, so first it will send a clock signal, pulsated signals. Okay. According to this pulse, the data 1 0 1 0 1 0 will move to the slaves. So using this SM communication, this one is IO. From IO, it will communicate through the slave. Slave may be charging IC or battery. Okay, these two are connected, right? So first the IO will communicate with the first one, charging IC is DACL. The charging IC all requirement is okay, then it will start communicate with the battery. It will check the battery requirement, battery current and battery is connected or not, everything it will check with this slave. Okay, so once battery is connected and battery requirement everything is connected, the IO send a signal to charging IC to charge this battery, right? It will talk to each other. For example, charging IC, battery and IO, these three will talk to each other through this SM bus I to C. In type C also I already mentioned that I to C. So that's why keep it in your mind, I to C is very important, even SPI also very important. If you know the communication, then it's very easy to do the service. So that's the reason again and again I am repeating. See, this is the way to communicate. Okay, these two pull-up registers are very important. Okay, the technology, so many technology, TTL and so many things I already explained in previous videos. Those you can check what is the TTL technology and all. According to the TTL technology, input will be 3.3 volts and here 3.1 volts you will get. So through this pull-up register, the slaves will be connected. Right, slaves in the sense other devices. Here is the main devices. See, the main devices is called master. So the secondary device is called slave. Slave in the sense not like normal slave. So it accept the commands from the master and communicate with each other. Okay, this is the one. What is that? I to C. See, here it communicate only through these two, data and clock, two signals, and one more signals it has through the request signals. In some cases it comments. See, for example, two slaves are connected here, slave 1, slave 2. It sends a signal to do a work. So then according to this, a acknowledgement goes here. That means it's a request. Through this request, REQ hash, you have seen in some schematics, REQ hash. Through this, the command, yes, I am ready, I will do. That command will go to the master. Then the communication will happen. The same thing here also. Sometimes 3 signals it will work. But the thing is, here compared to SPI, so this is slow, little bit slow. The communication speed, see, it may be 100 kilohertz speed to 5 megahertz depending on communication skills. See, depending on requirements, this I2C has used in laptop motherboards. Now you got my point, right? So one is I2C. Through the I2C communication through the SM bus, the charging IC and battery will communicate and battery will charge. This is the first point. And one more communication part, it's a very famous one. Second one is SPI, serial port interface. See, in I2C we have seen only 2 or maximum 3 connection, but in SPI it contains total 4 communication. Total 4 communication path. But IC may be 8 leg, but it has 4 communication part. One is, see this SPI deeply I explained in previous videos. You can watch that video, you come to know what is that SPI and what is that bias and what the requirement and how it will work. Okay, those things in previous video it is there. The one is MOSI, second one is MISO, third one is CS, fourth one is clock, CLK. MOSI, MISO, CS, CLK. What are those things? See, MOSI, M means master, S means slave. Okay, master out, slave in. This is called master out, slave in. This one is master in, slave out. Master in, slave out. Okay, this one is chip select. Chip select. This one is clock. See, for every communication, this is very very important. For every communication, the pulse or this one is required. Okay, to carry the data 1 and 0, 1 and 0. Okay, how it works, how SPI will work. See, this SPI, nothing but bias IC. The example, actually, that is the one of example. Number 1, it's a master. Here, one more is the slave. Okay, the communication total 4. How it will communicate with other one? That also same thing. See, this one MOSI, MISO, CLK, and last one chip select. See, one more important thing is these 4 parallelly we can connect to other slave. But the chip select we can't connect parallelly. Chip select is only for one particular slave. See, for example, if it is a slave 1, it means slave 2. This particular slave chip select, one more is required. 3 may be the common things, but chip select will be the separate in SPI technology. Okay, in bias IC, so you can see internally that MOSI, MISO, clock and chip select will be there. Chip select, when it will be low, then it will start communicate with that particular slave. For example, CS2, if it is a low, then this CS2 it's working. Initially it will be high position. Okay, when it will be high, then it's idle position. If it is a low, then this is in active position. Now you got my point, right? So in this particular motherboard or any motherboard, will talk to each other through this protocol. What are those protocol? One is I2C, second one is SPI, and third one is UART. UART are not using, so it's very slow. We are using only I2C and this SPI. Okay, in schematic I will show you. Actually, this is compared to I2C. Compared to I2C, it's very fast. Okay, it's more than 5 megahertz to 25 megahertz or 100 megahertz or 300 megahertz and so on. We can use SPI. Just example I am giving, not exactly. The more than 5 megahertz, up to 5 megahertz I2C we can use, but more than this you can use SPI. Okay, compared to this, it's very fast. So now you come to know how the motherboard will talk to each other, means each component smart works. So using these communication only, it will do the smart work. Once you give the all required voltages, okay, using high low pull up and pull down resistors, so it will work. Now 1 minute. I will take an example of schematic. I will take an example. See, this one is, what is this? This one is LAG07FP schematic. Okay, in this, just you can watch how it will communicate. See, this is the black diagram. Here IO is there. See, IO through this SM bus. SM bus 1 is communicating with the battery and charger. Just I already explained, right? Through this SM bus 1, this charger and battery will work. Through this SM bus 2, the DGPU thermal sensor, fan, light will work. It will work. See, these smart ICs will observe the thermal or current or voltage related or display related, everything. The sensor will be there, so sensor it will work first. So here SM bus 2, it has connected to thermal, DGPU, fan, and that PWM section, analog to digital and digital to analog, those sections also will work in this particular EC. See, touchpad also connected to here, keyboard also connected to EC through that SM bus. See, second one I told, the major one, see this PCH and CPU will work through SPI 50 megahertz. See, 33 megahertz is LPC. Here actually internally it required up to 100 kilohertz for these components. Here more than that required, so that's why through SPI communication will happen here. See, SPI 50 megahertz here it's showing 8 MB data SPI ROM has used. ROM is the BIOS chip, so it's a reprogrammable BIOS chip. Through this the program has to be done. So through that commands, these particular smart ICs or smart components will work. Okay, see, UC2 TPM devices all are connected through this SPI bus. See, SPI is not connected to other, so other one is not connected to SPI ROM. SPI ROM is entirely different. Okay, SM bus is entirely different. SM bus indicates I2C, that SPI indicates BIOS. Okay, now you come to know how it will work. Okay, one more example here. Yes, here. See, in this we can see the clocks. See, SML, clock and data. Through this prime 3 volts it has connected to where DGPU thermal sensor, and here G sensor battery charging charger has connected to EC. So through this communication the laptop will work. Without this communication your laptop 100% dead. What are the things, what are the voltage, what are the signal you pass it, so there will be no use without this I2C and SPI. This is very important topic. So if you want do in advanced level chip level services, then this point you have to be note down. See, one more thing I wanted to tell you, especially I want to say thanks to all viewers, YouTube viewers, because I already reached 3.2k hours, means 3200 watch hours I reached. Remaining 800 as soon as possible I will reach. So for this 3000, so that what is that paid option also opened. So you can watch my paid videos also. In that what are the hidden things which I not explained in this free videos, those things you can able to see. So every time I was telling it's only for PELC students. Okay, some hidden things I showed there also. So please, if anybody want interested to membership, so you can check my YouTube thing. So then you can add the membership. You can join our membership also. Okay, that's it. Thank you very much. If you have any queries, so put it in comment box. Thank you.